What up, YouTube? This video was taken on this Friday morning, November 25th, 2016. Time right now is 10:52 a.m. And it's Black Friday today, but I'm not gonna go shopping. I'm gonna do a project. So in my kitchen here, I have this light, this box light that has two T12 U bulbs. And the ballast is getting a little weak. Let's see if it'll light. So it doesn't want to light. The ballast is weak. But these are old school inductive ballasts. So if you stroke the bulb, they light. So I'm going to get rid of this old T12 stuff. So what I did was on eBay, I bought 100 of these LED. These are 6500 Kelvin. So they're white LEDs. And then I bought these from the same seller, these little power supplies, 12 volt, 5 amp, not UL listed. So hopefully it doesn't burn my house down. But I bought 2 of these because one of these will not control. I bought 2 of these because one of these will not control all 100 LEDs. Although I don't think I'm going to use all 100 modules for this light. I just wanted to have enough. Plus, I wanted to have another one in case these burn out, since I'm sure these are cheap. And I also wanted to get one that was small enough that I could fit it in the old ballast channel. So, let's get to it. So, first things first, turn off the power. Let's see, these are 40 watts each. Cool white, FBOC WXC. So for those of you ballast and light fixture enthusiasts, this is an Advanced RM 2S35TP rapid start ballast. It's for F30 T12s, F40 T12s, which is what I have, FB40 T12 ES. Actually, let me see. Yeah, actually I have FB4, so I think the FB stands for the curve. I don't know if you can see that, but it has a seal. Don't want to break the seal. I'll lose the warranty. Well, it looks like I'm going to have to drill my own holes. The problem is the mounting holes are on the back here, but it's kind of being covered by the circuit board. So I got to figure out how I'm going to do that. Okay, so I have a crap load of these white self-tappers they were left over in my shop when I bought this house. So I'm going to use 2 of these, and what I'm going to do is I'm going to install them, and then I'm going to I'll put one in, and then the other one I'll put in, and then I'll put in, and then I'll try to turn it in like that and see if that works. Another thing is, so my ground is tied to my fixture, because that's how ballasts work. The ballasts get their ground through the middle of the chassis ground of the fixture. But this one has a power ground. Now, I looked in there, I kind of peeked in there. This power ground is just going to, it's isolated on the circuit board. It just goes, it does nothing. It's not connected to anything. And then I'm looking, and I don't even think that the circuit board is grounded to the casing, but I'm going to go and ohm it out. Okay, so I have my meter here on continuity. Nothing. I mean, you see, so this is like a fake ground. Oh, hold on. I got continuity. Oh, I was accidentally touching this other case. So this ground terminal is a fake ground. It does nothing. So you don't even have to hook up that ground. That does nothing. The case will be grounded through the contact with the fixture. So I don't even know why they put that on there. Okay, so now let me check to make sure that the ground is. You see, so now we're getting a ground bind on the chassis of the power supply through the earth ground from the fixture. And you see that ground lug that they have on there does nothing. But we are getting a good ground there. There's also a little plastic piece that prevents the circuit board from touching the chassis, and I made sure that it was, when I put the screws in, it was on the other side of the screws. Okay, let's see if I'll be able to properly space these out. There. Oh, it's there a little bit. 4, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. So the question, I was originally going to butt splice this, but it looks like it's better to solder it since the wires are so thin. Okay, let's see what this looks like. Well, unfortunately, it's not as bright as I thought it was going to be. Whoops! But I guess I'll just press on forward. Okay, now that it's a little darker, I thought I would go and show you how much light it throws out. So it does light up the place. It's definitely a lot darker than the original lights, but I think I'm going to keep it the way it is and see how it goes. I do have a fluorescent light above that window and that window, so I can light up the countertop if I'm actually cooking or anything. And real quick, I wanted to show you how I did the calculation to make sure that I wasn't overloading that power supply. That power supply said it was rated up to 5 amps. But you know, it's China junk, so you don't even know if it is rated up to 5 amps. So you have your two formulas. You have pi, which is power equals current times voltage. And you have E equals IR, which is voltage equals current times resistance. Well, we only need pi here. The eBay listing said each module was 3/4 of a watt, and I put 40 modules in. So 40 times 3/4 of a watt is 30 watts. So then we use pi. So P, power, is 30 watts, equals I. We need to find out how much current we're drawing. And E, voltage, is 12 volts. So you divide both sides by 12, and you get 2.5 amps. So that power supply says it's rated for 5 amps, and I'm loading it down at 2.5 amps. So theoretically, that power supply is hardly having any load on it and should never burn out. But like I said, it's China junk, so that's the only thing I'm a little leery about, that power supply. But only time will tell, you know, how good that power supply is. So I hope you enjoyed the video. Thanks for watching.